Hey guys, today we have a very short section for you, section 7.3, separation of variables. I do want to let you know about a little bit of information about the AP exam regarding separation of variables. If you have a differential equation problem on your AP exam, and let's say it's worth, the part about separation of variables is worth 6 points. If you don't separate your variables, even if everything else is correct, you would get 0 points. So separation of variables is extremely important. You are going to put all your y's dy's on one side, all your x dx's on the other side. Then you're going to take the antiderivative of both sides. And for some, you're going to find the general solution, and for some, you're going to find the particular solution. So as we look at part A, we cannot go ahead and take the antiderivative of both sides because our variables are in both fractions. So we're going to rewrite as y dy equals 2x dx. And then we're going to take the antiderivative of both sides. So y squared over 2 equals x squared plus c. And as you can see, normally we would put c's on both sides. And yes, we would, but we're only going to put one c in here because c would represent any constant that we would get if we had a specific set of information that would help us find a particular solution. So sometimes you may see C1, sometimes you may see C2. Bottom line is C is just going to be that constant. So I'm going to multiply 3 by 2, and I'm not going to mess with that C, except I'm going to say this becomes C sub 2. And the reason I'm doing that is because if I multiply by 2, that's going to change the value of C, but I don't know what C is. So we're just going to put C sub 2 here. So when you solve for y, because that's your goal, you get plus or minus square root of 2x squared plus c sub 2. That is one way that you could see this written. The other way you could see this written, and I'm going to put it right up here, is 2x squared minus y squared equals c sub 2. So sometimes you may see a problem where it's solved for y. Sometimes you may see it solved for c. It doesn't matter. They're equivalent equations, but you just have to look, especially if it's multiple choice, just look first to see, is it solved for y or is it solved for c? That's the procedure you'll follow for every one of these problems. All right, so separate your variables. Dy over y squared equals dx. Integral on both sides. This is y to the negative 2. So let's see, y to the negative 2 plus 1 over negative 2 plus 1 is negative 1 over y equals x plus c. So let's do y equals 1 over x plus c. Just flip your fractions. Okay, part C, dy over y equals x dx. Ln absolute value of y, we are integrating, equals x squared over 2 plus c. Now, our y that we are solving for is inside of an absolute values. This is going back to your logarithm rules. To get rid of that ln, you have to make these sides exponents of e. So y equals e to the x squared over 2 plus c. Here's another side note. E to the 1/2 x squared plus c. Addition implies multiplication when you're dealing with logarithms. This is the same as e to the 1/2 x squared times e to the c power. So e to the 1/2 x squared, we can say that that value is k. So y equals ke to the 1/2 x squared. Okay, would come out front here. If you see y prime, go ahead and write that in as your dy dx. So 4y dy dx, take that 3e to the x to the other side dx, antiderivative 2y squared equals 3e to the x plus c. Solve for y squared first. And y equals plus or minus square root 3/2 e to the x plus c. Or you may see this as 3e to the x minus 2y squared equals c. So take your 3/2 over, it becomes negative, multiply through by -2, which would give you the solve for c. Separate your variables, 3y squared dy dx equals x squared plus 1 dx. I'm sorry, guys, we need to take this dx off because we're separating our variables. I'm sorry about that. Antiderivative. So this is y cubed equals 1/3 x squared plus x plus c. Multiply by 3. And bring your terms over. 3y cubed minus x cubed minus 3x is equal to c, or y equals the cubic root of 1/3 x cubed plus x plus c. Now we're going to look at particular solutions. When you are given specific information, that just means we're going to be solving for c. So our general solution, we're going to do x dx equals e to the t dt. So x squared over 2 equals e to the t plus c. So there's our general solution. Before you find a particular solution, you always have to start with a general solution. All right, now we're going to find c, and we're going to use x of 0 equals 1. So 1/2 times 1 squared equals e to the 0 plus c. E to the 0 is 1, so c is equal to -1/2. And now we're going to find your particular solution. So 1/2 x squared equals e to the t minus 1/2. Then we're just going to multiply 3 by 2. Typically, you're not going to see too many fractions, especially out front. All right, y dy equals 1 plus x over x dx. Antiderivative y squared over 2 equals, I'm going to split this up, 1 over x plus 1 dx. So y squared over 2 equals ln absolute value of x plus c. So we're going to use y of 1 equals -4. So we have 1/2 times y squared equals ln 1 plus 1 plus c. This is 8 equals 1 plus c. ln 1 is 0, so c is 7. So y equals -2 square root of ln x squared plus 2x plus 14. And multiply through by that 2 and take the square root. Now, x cannot equal 0 and y cannot equal 0. If you look at that original equation, so you do need to make sure that that is specified. And you can do that as soon as you get the problem. All right, last one, you're welcome to pause your video and try it on your own if you'd like. So y to the 1/2 dy equals negative x to the 1/2 dx, and integrate both sides. So 2/3 y to the 3/2 equals negative 2/3 x to the 3/2 plus c. So y to the 3/2 equals negative x to the 3/2 plus c. So we're going to find c with y of 1 equals 4. So we have 4 to the 3/2 equals negative 1 to the 3/2 plus c. So 4 to the 3/2 is 8. Negative 1 to the 3/2. Let's see, what might I have done wrong there? Oh, the negative's out front. So that would just be our 1. I'm thinking I may have made a mistake in here. Just a second. I'm going to pause the video and come right back and see if I can figure that out. Okay, guys, sorry about that. I realized when I went to do my substitution that I was substituting into the wrong place. So what I've done is kind of started the process over. So if you are to a place where you can get back to this, or if you want to pause and do it on notebook paper, that's perfectly fine. So this is the point at which I want to find y of 1 equal to 4. So as I am looking here at y of 1 equal 4, I'm going to plug in and get 2/3 times 4 to the 3/2 equals negative 2/3 times 1 to the 3/2 plus c. And when I use my calculator and plug that information in, I get 16/3 equals negative 2/3 plus c. So c is 6. And then when I go to plug that back in, that's when I can simplify my values here by my 2/3, but I've got to remember that now I have c, so I need to accommodate that in my problem. So if I have y to the 3/2 equals negative x to the 3/2, I need to include that 3/2 when I multiply by c. So this is going to be the cubic root of y. So I'm going to bring those all over together. So I'm going to say x to the 3/2 plus y to the 3/2 equals 9. And that's going to be the square root of x to the 3rd plus the square root of y to the 3rd is equal to 9. And this will be my particular solution. Thank you guys for being patient. Sorry about that. Every now and then, we all make mistakes. So let me know if you have any questions, and I hope you guys have a great day.